let's talk about what is DBT and how it could help us in our everyday work. So probably you know, so let me remind you the history of the data processing.
Slava, you are on mute.
Slava, we don't listen you.
Yeah, we can't hear you.
I've just wondering to stop my video just to release the internet channel, but
Okay.
unfortunately, instead of that, I was always putting myself on mute. Sorry for that. Okay, let me remind you just how the IT systems build. Anyway, when you build any IT system, it should be built around the data. Data should flow into the IT system, transform inside, and probably flows out the system to numerous downstream. Yeah, and certainly when we are working with the data, there are some areas which is very carefully and very important for us. It's data itself, it's data complexity, it's a speed of processing, it's ability to use something like the translations, polyglot ability, and something like that. It's data compliance and the transparency of the process as a whole. And from the very beginning, it looks like that data was built by using the simple applications on the quite high-level programming languages like Visual Basic or C++, or any databases or databases-like systems like a Fox Pro, Microsoft Access, and so on, so on. Then processing changed for a while, and OLTP applications with relational database management systems are in a place, and most people started to work with such kind of approaches. This, let's say, era let us ability to generate reports, to work with data itself, and to think above the data, not for the just programming languages constructions, but for data itself and how this data could be used for our business needs. Then the era of BI reporting came. So BI is a business intelligence. So databases became more and more powerful. The ability to grab the data from there also has been increased. And era of the BI reporting came at this stage. And the next stage is very, very important for us, because at that time, the famous abbreviation, which is ETL, come into our world. So what is ETL? ETL is just abbreviation for the extract, transforming, and loading. And if we will see on the diagram, it's quite simple. So we have numerous data sources like upstreams. So we grab the data from there and put into the specific area, which called the staging area or operational data store. It's there a bit different between those terms, but anyway, let's say it will be the staging area. And then we will be transforming this data and put into the common layer, into the normal forms, into the tables which can be using for the many reports across the company, for building the analytics, all up cubes, and so on, so on, so on. So it's quite simple. And the main focus of this particular paradigm, which is ETL, is to not overload the source systems. So the process were defined this way just to not overload the source system, because computational capacity was not so high at those ages, and we need to grab the data as much fast as we can, ideally at the night when the business not in the workplaces. Yeah, so we are grabbing the data from there and trying to transform them on fly, because our storage capacity is not so huge. The storage is quite not so cheap as expected, but computational capacity is more high than in comparison with the storage, and we are trying to transform data on the fly before land this data into the common data warehouse part. Several years after that, MPP systems were into our world, so it's a massive parallel processing. The first competitor on the enterprise layer was Teradata. They have provided the appliance for processing really terabytes of data. It's not a joke. It's not just a marketing or PR step. It's real information. So many terabytes could be stored inside and processed incredibly fast. And at those times, the interesting players like Hadoop also come into our world. So Hadoop is also some kind of massive parallel processing, but based not on the powerful machines. The main idea for Hadoop was just let's using the commodity hardware like usual PCs or something like that, just to store terabytes of data and trying to process them as much faster as we can. And currently, we are at the last stage of our diagram. So we are using the cloud architecture and hybrid architecture. We are using the stream processing. We are using the indexed search and full text search. And at this stage, we can see that ETL paradigms are slightly changed to the ELT. So the main idea is quite the same. We need to grab the data from elsewhere and prepare for the analytic purpose. However, the logic inside was dramatically changed. We are extracting the data and put into cheap storage like a Hadoop, like a S3 buckets or elsewhere. And then we have the transformation logic, which prepares the analytical data for end users, for downstream systems, for any dashboards, reports, and so on, so on, so on. So paradigm has changed from the extract, transform, and load to extract, load, and only then transform. Certainly, this is just a simplification of real process, because if you will see on the real applications, you will be seeing that the actual process looks like extract, load, transform, load, and probably some combinations of LT letters at the end of this abbreviation. But to simplify the procedure, let's say that we have just 3 letters there: extract, load, and transform. And what we have in our hands for the nowadays, we try to process many and many data from day to day. We try to store as much data as we can with slogan like, okay, let's keep this data for a while, probably it will be helpful somewhere in the future. And currently, we have a lot of information around us. We have a lot of information inside our IT systems, and these data silos could be and should be managed somehow. So how we can schedule those jobs? How we can ensure that those jobs are completed successfully? How we can know at least that it's doable in principle, or it's just an ephemeral thing like a spherical horse in the vacuum? I don't know. And let me show you the interesting player on the ELT world at the moment. This player is quite young. As I remember, it's only 3 years for this particular product. But let's assume that we have the solution for the T letter inside the ELT abbreviation. We can use any data extractors. For example, Talent, Apache NiFi, I don't know, Spark or Kafka or any other tools which will be put the data inside our data warehouse, yeah? Or inside the buckets or elsewhere. Yeah. And currently we don't care about the downstreams because there are a lot of BI systems in the market. Business Objects, Cognos, Elasticsearch, Looker, Google Data Studio. There are many tools which help us to build the analytical reports, to build the regular reports, and make some ad hoc queries to our data. Let's concentrate in the middle of this, in the middle part of this process. This is a data transformation. DBT will not extract the data. The DBT will be running the process on the same database just to transform the data from one kind to different one kind. That's only function for DBT, but this function is incredibly managed and transparent for usage. So here you can see the example of nowadays data warehouse. So we have some data sources, we have some extractors and loaders, Airbyte at this particular slide. Then we have, for example, BigQuery as a storage for the data, because not sure you know or not, but on the BigQuery we have 2 different pricing models for the data, and if this data is not actively used, let's say it's in the partitioned tables, and those data not changed during last 90 days, this data will be treated as cold data, and you will be paying only 10 cents for per the gigabyte for this data storage, which is nearly the same as for storage in the buckets. So we can store the information not only in the buckets but directly in the BigQuery using the same pricing model. It's really incredible. And then we have the data modeling tool and data transformation tool, SQL based, like a DBT. Then we have analytical data marts, let's say in the BigQuery also. And certainly then we have, should we have the BI and visualization tools like Looker, Metabase, and any else. Yeah. What else we need to have in our hands just to ensure that all works fine? Definitely, we nowadays we definitely need to have the version control, because all scripts, all the processes, all cron jobs should be versionized and easily retrieved for any version. Yeah. We need to have the testing capability, so how we can test the data, how we can test the data pipeline, and ideally we need to have the solution for something like a data catalog, just to have the ability to understand the data which we are trying to process. Yeah, data initiators, data owners, the purpose of this data, the data freshness, or how fast we should load this data, what are dependencies there, what's the physical storage for them, and so on, so on, so on. Any metadata for our data is very, very useful for us. And from this perspective, let's talk about the DBT and trying to get the answer whether DBT is proper tool for us or not. Because currently it's just an abbreviation, which is data build tool. Okay, fine. And we don't know whether it's helpful for us or not. But let's assume that if you have positive answer on the items stated on this slide, we can treat that DBT is proper tool for your purpose. So let's try to elaborate a bit more for each of these items. So why your analytics warehouse should be on the separate hardware from the product databases? Because the most of upstream systems should hard working to their business functions. Yeah, for example, for network routing, for the calculation of any pricing models or any else processes, which are completely separate from the analytical calculations, which is suitable, for example, for the marketing department or for the CEO or any other personnel. Yeah? So let's treat that our upstream systems using their own hardware, their own network, their own processes, and so on. And our data warehouse will be grabbing data from there and put inside just to calculate, transform, and provide the analytical reporting based on the data. It will be helpful. And the second statement. We just told that DBT is not a data extractor. Yeah. So we definitely need to have some instruments which will be grabbing the data from upstream systems and put inside the staging area or data lake of our data warehouse. Yeah. So DBT will be working inside the same data warehouse. DBT will be using the data from the data lake or from the staging area or ODS area of your data warehouse just to transform this data into the forms which is suitable for the analytical purposes and reporting purposes. And depends on the data warehouse provider in your landscape, you could see some statements related to that. So from the box, DBT supports let's say 3 major cloud data warehouse providers, such as Redshift, Snowflake, and BigQuery. Yeah. So in case of BigQuery, for example, you will be using the single BigQuery account, but certain service account. But this account should be able to access data into the one or more GCP projects. So let's say we have the different projects for different purpose. So definitely our service account should be able to grab data from there, from all of them, and put into the data warehouse. So this is a limitation. Yeah, quite the same situation for Redshift and for Snowflake. And this third statement, the DBT as a SQL-based tool. So in other words, anyone who knows SQL can work with DBT. From one point of view, it's a limitation. Yeah, so let's say SQL is not a real programming language. There are a lot of things inside which are not allow us to make the proper transformations and so on, so on, so on. But in the other hand, we have the situation that nowadays we know that many people knows SQL. Data analytics know SQL. Business analytics know SQL. Many people know SQL. So if we can provide the instrument which is SQL based, we can definitely help them to work with the data without involving the IT department of their organization. Why not? It's quite simple and useful. So from this perspective, DBT is completely SQL-based tool. Your data transformation should be able to be described in SQL terms. And if this happens, okay, fine, DBT is your tool. You can use it. There is an interesting ability inside DBT. You can write user-defined functions on the Python or JavaScript. So let's say we have the SQL plus extension of it. So if your staff know not only SQL, but the JavaScript or Python, definitely you will be happy because you will be able to write the more comprehensive transformation using the same resources. And the next statement regarding the batch processing. DBT is not streaming tool. It's truly batch processing tool. Quite the same situation as first my confused regarding the Spark streaming. Probably you know that Spark streaming, despite the name, it's a micro batching tool. From this perspective, DBT is truly batching tool, so not treated as a streaming. Even if you will run it continuously, let's say run again, it will not become to the streaming world. It's a truly batch processing tool. So we need to use it in a batch process. And to be honest, I know the very limited amount of situation when the real-time analytics were useful for some companies. In most of cases, analytics do not need real-time data at all. They need to have the data acquired from different sources and combine it into the single report, for example. In this case, we need to ensure that all data has been received, data is compliant, data is clean, and only then we will combine those data between each other and prepare the analytical report. So in most of cases, streaming analytics is not required. And in this case, if streaming analytics is not your case and your analytics, your data consumptions, data consumption tools can use the batching approach. So DBT is your tools in this case also. And the quite interesting thing, your data transformations should be idempotent. So that means that if you will be running the same transformation again and again and again, the result of this transformation should be the same. DBT is built around the select statements. So you don't need to write insert or merge or update or anywhere else. No, you just write in the select statement, and depends on the conditions, this select statement will be transformed into create or replace table using this select, or insert data using this select, or merge data with deletion or absorption, or just insertion of this data using your select statement. All of this stuff are fully managed on the DBT side. You don't need to write those complex procedures and complex logic. You just need to write the select statement, which is very simple. And this is one of things which help us to use DBT for non-experienced data analytics, because they definitely can write the select. They probably don't know or don't have the permissions to manage the data, to update the data, or they scared about updating the data because it's production. Okay, fine, but they definitely can write select statement, and this is really helpful for them. They write in the select statement and run the model inside the DBT, and DBT will transform or will use this select statement just to provide the comprehensive and proper data management procedures, especially from the conditions of this model. And on this slide, you can see the small visualization how DBT works from the console or CLI mode. So in brief, you have two components like compiler and runner. Yeah, user will be writing the SQL statement. Those statements will be compiling using the DBT commands, for example, like DBT compile or DBT run. Yeah. Those statements will be compiling, and the SQL statement given after this compile stage will be executing against the configured database in the backend of this process. Quite easy from understanding and quite easy from the usage perspective. And regarding the backends, here you can see the list of adapters which are helpful to connect DBT to numerous backends. On the DBT-labs, which names of the name of a company, which is founder of the DBT. Previously, it was Fishtownanalytics. Currently, they are DBT-labs. Okay, fine. And DBT-labs supports the 7 adapters. One of them is partially supported. Core, this means this is a CLI version. And cloud, this is a cloud version of the DBT. And on the right side of the slide, you can see the community or vendor supported adapters. So I really hope that you will be impressed by the amount and kind of backends which will be suitable to work with DBT. Or in other words, to the number of the backends which can be useful while you are working with DBT. And from the helicopter view, we can see that DBT contains from the components which are listed on this particular slide. It's quite simple, quite easy, and nothing special or hard in this case. And certainly, currently we have not comprehensive course for the DBT. It's just a helicopter view on this tool. And let's try to explain those components in more verbal way. For example, in this, DBT enables you to, certainly you can model your data warehouse tables and views using SQL statements, and DBT models will be using for that. You can test the data quality and data structure and make any other tests like bespoke tests or any other test against this data and data structure using the DBT test. You can check the data freshness by using the DBT snapshots. Moreover, the construction of the DBT snapshot can help us to use slowly changed dimensions type 2 without writing any additional code. You can document the metadata of your data warehouse processing in quite easy and fully automatical way. You can discover your tables with DBT Web UI or using the Cloud Data Catalog. There are possibilities inside that. We can visualize dependencies in your data processing using DBT UI. We can use the packages written by different users, or even if we can write our own package, we also can use this packaging function from it in our data processing, and we also can publish those packages on the DBT hub in the worldwide network. We can make incremental snapshots of our DBT tables. We can share our queries for different, for example, organizations or departments using DBT analysis, and we can track the dependencies and make some metadata about our data consumers using the DBT exposures. So I'm just trying to represent those components in more verbal way, just to emphasize what should be done and how it should be done, without reading a tons of documentation. But if you will see on the end of each item, you can see something like the link. It's really links. So when you will be opening this presentation and clicking on those links, you will be redirecting to the corresponding chapter into the DBT documentation or DBT description, just to ensure that you will be understanding these terms properly. And from certainly, we can talk more about each of those components. However, the core functionality and the, let's say, skeleton of the DBT is built on top of the DBT models. So model is a main entity for all DBT processing. Yeah. And let's talk a bit about DBT models. What is DBT models? DBT model is a file with SQL extension and select statement inside. There could be also some macros, some configuration items, and many other things, but in general, it's really enough just to use SQL statements inside those files. This file name will be using for reference if you will need to call this model from different model or to join this model with different model. You will be just calling this model by using its file name without extension. It's quite easy. And certainly you can use the nested structures of several subdirectories just to organize your files in proper way and just to ensure that path of the access to the file is really explain the situation and probably the area of processing or any other tools and places which will be suitable to understand what the data could process. Yeah, and when you will running the dbt run command, in fact, DBT will try to compile all your models into the appropriate files. Depends on the configuration. It will be prepended by the create or replace view as or create or replace table as using your SQL statements. And those configuration for your model have a name materialization. So let's probably discuss a bit more. The SQL statement will grab some data from some table, yeah, and prepare the information. But this information should be landed somewhere. This information should be persisted somewhere. And this persistence for those SQL statements calls materialization in DBT terms. So when you will be configuring your model, you could use the different kind of materialization. So let's probably go one by one in this list. First of all, it's a table. It's quite easy. So this SQL statement, select statement, could be stored at the same database as a different tables. Let's say create table as select in this way. View, quite the same, but the actual persistence wasn't happened. We will be just storing the compiled SQL statement inside database, but not store the data. That will be expressed as a create or replace view as select statement. Yeah. Next one is a incremental materialization. It's quite interesting. So let's assume that we have a lot of data inside. Yeah. And the process like create or replace table using SQL statement, it's quite long and costs some money for us. And let's say we will processing the data, for example, for 100 terabytes. It definitely will be costly, and it definitely will consuming a lot of time. Okay, fine. So let's try to see in that process in different way. We can process not only not the whole data. Let's process the data which we are receiving since the last batch. So let's assume we just finished successfully the previous batch, and before running next batch, we definitely will receive some data in our staging area. Okay, let's process only that data which is flowing in during the period of silence for our batch. Yeah? And when we will be putting this data inside our analytical data store, we can use different strategies. So it could be just insert, it could be the replace of existing data and insert new data, like upsert, yeah, and it could be the full delete and full insert. Depends on your need. All of these strategies could be expressed by using the incremental materialization, and certainly we have some pros and cons. Yeah, as a pros, you can significantly reduce the build time for this transformation and running time for this transformation. Yeah, but the cons is the quite interesting. The incremental models certainly requires extra configuration, and in addition to that, it requires the advanced usage of the DBT. It's not, so from the user perspective, it's just the same SQL statement. But if user will choose the incremental materialization, this user should really understand what will be the result of this data processing. So it's probably it will be not so easy for understanding. Thus, incremental. Let's put this particular part like additional knowledge in a codes. Yeah. The next one is ephemeral. Ephemeral models are not built directly into the database. So let's say the ephemeral model will be preparing the part of SQL statement which could be used as a common table expression, like with blah blah as select statement. So, or name it SQL part. So ephemeral is just for this purpose. You can define this this part one time and use in many places just to avoid the code repetition. It's quite famous. And the last one is a BigQuery specific adapter materialization, which is copy. BigQuery can support you to have the copy of your data in couple of seconds without any charges for you. I was really impressed because I need to copy my database table, which at that moment, as I remember, about 70 terabytes in one table, and that table have been copied into different tables within 25 seconds only. It was really impressive. And the interesting thing that copy operation costs 0 in BigQuery. So this particular materialization allow you to use the BigQuery copy API from the DBT side. So let's say it reduce your costs and certainly processing time. And the next thing is quite interesting. So, okay, let's assume we have tons of models inside our DBT project. Yeah. How we can know that those models will be running in proper order? For example, if we have, let's say, staging orders, fact orders, analytical orders, and so on, so on, so on, how we can ensure that all data processing pipeline will be running using the same order as I've just explained. Here you can see the real screenshot from real DBT project with tons of models and dependence between them. Probably it's not so visible because there are really numerous of entities, but let me show you a bit closer how it looks like. Yeah. So left table is a source for the 6 tables on the next stage. Some of that combine it into different 2 tables and so on, so on, so on. And at the end of this process, we have only one table, which is f-editor creation events, when we have combined and transformed data given from all previous stages. So all of this magic happens inside your DBT by using only 2 functions. First functions is a ref. As you remember, we've just stated that model SQL file names will be using for the reference of this table. So you're not, it is not required to state your, let's say, database name, data set name, table name, blah, blah, blah. You can just put here the name of your SQL model file. And when the final SQL will be compiled, that will be grabbing proper names from the configuration items. And you don't need to put those names or don't need to hard code those names inside the SQL file. Moreover, those references will be analyzed in the backward direction. Let's say if this particular model depends on the STG customers, STG orders, STG payments model. The next stage will be looking at that models, finding and defining the dependencies for different models, and so on, until the first model in our data pipeline. So from this perspective, we just need to write all corresponding SQL statements, put the proper names of models inside, and the data lineage magic will happen fully automatically by using the DBT tool, instead of writing the complex configuration like run this one, then run this one, then wait for those one, and so on. All those magic will be completely under the hood of the DBT, and you don't need to care about that at all. And the second magic function is a source. Let's assume that not all your tables will be populated using the DBT tool. Let's say we are using the staging area of your data warehouse. So some data loaders, external data loaders, will be putting data inside. Yeah. So we can't define the model for that, because model is a transformation. Yeah. So we just need to have ability to list those sources and just use them using the source function. In this case, you can see on the screen, so we will be using the source from the PDM configuration and using the item order from the PDM configuration. Again, you are not putting here the names of the dataset, databases, and database objects. This is just the names and sections of your configuration. So you can easily make changes into the single configuration file, and your whole pipeline will be working in completely different way. It's really amazing because I don't know you're familiar or not, but the main concept of the nowadays ETL pipelines are called as declarative ETLs. This means that ideally you should change the configurations only just to rebuild your pipeline as a whole. This is ideal state for nowadays. Yeah, but certainly we all will understand that it's impossible thing from the scratch. But using the several instruments like DBT, we can step forward much more than we expect. So we will be using configuration items here, and while we're changing the configuration, our pipelines will be changing also without any changes in the code. It's really impressive, isn't it? So here you can see actual dependencies, probably in more closely. We have several source tables on the left side. We have several staging tables. We have some dimensions or facts or any other additional tables. And as a result of processing all of those stages, we will have the one table which will be containing the metrics suitable for the analytics purpose. And certainly we should know how we can run those DBT pipelines in production. It's quite interesting because it's easy to run any tool on your developer machine. You can install, you can run, you can make changes in the code, you can do everything on your machine. But on the production, you are limited by the procedures of the rollout, by the procedures of the CI/CD pipelines, and definitely there should be the several ways how to use your instrument, DBT in this case, in the production environment. First of all, you can use the DBT cloud for that. DBT cloud is a separate cloud version of the DBT tool, and it provides you ability to use the schedule, to use to see the history of your running, to configure error notifications and alerting if you need this. But especially for me, DBT cloud is not so feasible to use because, or let me imagine, nowadays DBT cloud has the password only authentication and authorization. So you understand that you definitely need to put there some service account credentials or private keys, put some names, and so on, and all of that information are only the password authentication. For me, it looks ugly. So I expect to have at least 2FA there, but unfortunately, no, there is no 2FA, only password. So for me, the DBT cloud is not an option. Next one is Airflow. Probably you remember recently we had an event with Astronomer demo. So Astronomer is a, let's say, enterprise version of the Airflow implementation. Yeah. So we definitely can use Airflow to run our DBT pipelines. On the Airflow side, we have DBT Cloud plugin just to interact with DBT Cloud if you will be using it. We have the bash operator just to easily run construction like DBT run or DBT test or DBT seed or any else. We have the Docker Kubernetes operator just to ensure that we will be running our DBT pipelines in a separate instance, like a Docker container or Kubernetes pod. Yeah. And additionally, we have the Python package Airflow DBT Python, which could be easily installed on the Airflow machine. And we can use this particular part just to initiate our DBT pipelines. The next one is a Prefect. This is a orchestration tool for general purpose, but on the Prefect side, we have DBT shell task plugin that will really helpful for us just to initiate DBT pipelines. Next one player is a Dagster. Dagster is a open source orchestration tool, and this tool also has a plugin which name is Dagster DBT. Certainly, we can have the automation server like GitLab CI or GitHub Actions or any other tools. Jenkins doesn't matter at the moment. And at the last option, we always have the cron. So this requires the physical access to that machine, which we'll be using for DBT pipelines running. You can define the cron job for running the DBT pipelines. We also have this option if you need it, certainly. And here you can see some useful links. Let me show you. It's really links, so it's not just a text. For some interesting parts of the DBT documentation and DBT information. Yeah. Moreover, I've created my own Docker image for the DBT because in most of cases it's really strange because Docker, as I remember, Docker is about 12 years in the market, but nowadays many companies and many guys working with Docker is not so proper way. They build the huge Docker images like 1.5 terabytes each or something like that. And there are many unnecessary functionality inside. So I've just to segregate the functionality and make the Docker images more tinier. I've created my own Docker image, which is built on top of the DBT code. It's not using packages. We will be just grabbing the latest tags or proper version tags from the DBT GitHub, and based on that code, we will be compiling and preparing the Docker image. You can see on the screen that I've created several spins for the BigQuery, for the Snowflake, for the Redshift, and those spins quite tiny because the official Docker image, which is full, as I remember, its size is about 265 megabytes or something like that. So here you can see that, for example, BigQuery one, it's just 100 megabytes, 144 for Snowflake, and 110 for the Redshift. It's really much more tiny than full one, and you will not have the unnecessary functionality in this case. Anyway, you are free to use the official image if you want, or any else. Moreover, there is a DBT fundamentals course on the DBT side, so you can always use this online on-demand course just to grab some knowledge from there and to, let's say, to make your DBT strengths more powerful. Why not? And now we are nearly goes to the demo. Certainly, all of this information is probably interesting, but it takes our nothing if we will not see how it works. And let me show you how it works. So first of all, I will be using the one of this one. This is a testing DBT project provided by the DBT-labs company. I've just cloning this GitHub repo and add 2 files there, so you can see that only 2 files added to that part. First of all, is a profiles YAML. So this is the file which will be using or which will be configuring your database access. In this particular case, I will be using the BigQuery as a backend for our DBT jobs. So I am defining that type of database as a BigQuery. I will be using the service account authentication and authorization method. I will be using the our Big Data Analytics group demo project on the GCP side. I will be creating the DBT demo database, which will be situated in the EU location, and I will be using the file which describes the service account private key just to have access to those databases. And I really like to use Docker. And in this case, just to not write the long shell commands, I will be using the Docker compose YAML just to use only one command like a Docker compose up, just to run our pipeline. So what we will be using? We will be using my own Docker image, which is spin of the DBT, especially for BigQuery. We will be exposing the port 8080 just to review the documentation generated by the DBT pipeline. We will be attaching some volumes, this volume which is related to our code, yeah, this volume which is related to our profiles YAML, and this volume which is related to the appropriate JSON file for a service account. And as executive commands, we will be using the sequence of DBT commands. First of all, the DBT seed. So we will be grabbing the files from data catalog, like there are several CSVs. So we will be grabbing those CSVs and put into the BigQuery side. Yes, DBT has a capability to load simple CSV files using DBT seed command. But this is not main functionality. This could be useful for the testing purpose or for populating the really rarely changed data, like I don't know, calendar tables or something like that. There is a functionality, but it's not a main functionality. So we know that it's there, but let's not use it in production. Yep. And after that, we will be running all our models, not only one, but all. So we will see how the models will be situated, which order for the running will be using for that. Then we will be generating the documentation for this process, and then we will be up and running the documentation server. And just to ensure that our Docker container will not be closed after successful initiation of this command, we will be adding the tail -f dev-null command just to have, let's say, endless command in our container, just to ensure that container will be live all time we need it. And let's see inside. So we have the models here. You remember, the model is a SQL file, and its name customers will be using as a reference. Let's go into the staging part. So here you can see, for example, STG customer SQL. Yeah. And in the customer SQL, we are referencing this file. It doesn't matter what's inside this file. That could be the different logic. And we will be not putting the hard-coded values there. We just put the name of the model file, and we know that it will be working for us. So again, this is just a SQL file, nothing special. The only special thing is here, because actually DBT has extension. So let's say each model is a SQL could be extended by using the Jinja templates. I don't know, are you familiar or not with Jinja? But it's a templating language which will be interpreted as a Python code. So currently we are using the Jinja variable with ref function inside, just to reference corresponding model. All other stuff is completely SQL based. Certainly you can use here construction like direct database name, direct dataset name, direct table name, but in this case, why we need to use DBT? We can run those SQLs from elsewhere with the same result. The powerful of DBT is the automation of dependency and running the models in proper order. So for that case, we will be using the ref function to ensure that all our models will be running in proper order. In the schema YAM, you can see that for each model, you can define the description, which will be populating into the documentation side. You can add some tests. For example, in model customer, column customer ID should be unique and not null. And when you will be running the DBT test command, this particular model will be checked using those test statements. And if something goes wrong, you will be seeing corresponding messages, and probably you will be cleaning data before actual loading. Yep. And in addition to that, you can see some additional files like definitions of the diagrams and so on, so on, so on. But in general, to be able to run the simple project, you should have the set of SQL files, which SQL statements inside, and you will be just running it using the DBT run command. So let's initiate this sequence of commands by using the Docker Compose. Let's go. So here you can see we've just created the container. We know that we have 5 models. We have 20 tests for them. We have 164 macros and 3 seed files, so CSV, which will be loading. Yeah. So and here you can see, first of all, we are loading the corresponding CSV files into raw tables. After that, we will be running STG tables population, which will be grabbing the data from raw tables. And as a final stage, we will be running the models like customers or orders, which will be grabbing data from STG tables and prepare the tables at our end. So here you can see this is a state of BigQuery projects before this presentation. So here you can see that there is no DBT test data set at all. We just run those stuff. So if we will be refreshing this page, we should be able to see DBT test data set inside our project. Yeah, it's there. And here you can see some raw tables which populated from the CSV files. Let's review. This is just created, as you can see. Yep. In those tables, there are some information, there are some data inside regarding to that. We have several views. So if we will see on actual code, for example, for STG models, yeah. So this model, let me show you. So for example, STG orders, yeah. Here is just an SQL statement, you can see. But in DBT project YAML, for the staging area, we use materialization views. Those all models which are in the models staging folders, you can see staging here, will be using materialization view. There is nothing in the SQL. This is just a select statement. But materialization view, and if we will see on the database side, you can see that, for example, STG payments, it's an actual view with query inside. Hope you can see. It's not a table. But for the models which are in the root of models folder, like a customers or orders, we should use materialization like a table. So we should expect that STG customers, orders, and payments should be the views on the database side, and customers and orders should be the tables. Let's check. Customers and orders are tables. So you could see the table size here because there is data inside. You can see the data location and even long-term data storage, which is absent at the moment. There are 99 records inside. Yeah, those ones are tables, and previous ones are views. And certainly, raw tables are also tables because they are just a destination for CSV files loading. Let me just close up there. And as you remember, we discussed that we will see the documentation generated by this process. As you can see from the log, we generated the documentation and up and running the web server, which is accessible by using this link. So here is the documentation generated by DBT itself. The mostly interesting part is data lineage. So here you can see the actual data lineage for each table. For example, table customers is populated using the data lineages on the screen. Quite the same for orders. If we will use the STG customers, so we'll know that one source to populate data in and one source to outjust data from. And the same here. So is a full data lineage for all your models. Here we have quite simple model, only five objects. I don't care about raw at the moment. Only 5 objects inside, but even in this case, the proper order rules, because we need to load data into the customers tables. Then and only then this data is loaded into the 3 tables before and acquired from the 3 raw tables. Only in this case, we will be loading data into the customers. If something happens here, for example, these tables could not be loading for some reason, this process will stop here. And you remember your data pipelines, the data transformation should be idempotent. It doesn't matter in which part of this process you will be failing. You can easily run those pipelines from very beginning, and the result should be the same as for running the whole pipeline. And in addition to that, we have fully documented solution. What we have, for example, on the database side, we have project name, we have data set name, we have name of the objects, like a customers is a table which has a description, which has particular data types with column descriptions and so on. We have the references for this table, we have dependencies for this table, we have the source, which is written here, yeah, and we have the compiled SQL, which will be running against the database. So here you can see, as you remember, here we are using the ref function. Yeah, if we will see on the compiled case, you can easily define that this particular reference function have been replaced by using the actual names of the project, of the data set, and of a table. It's quite easy and quite simple from understanding, and you don't need to manage those dependencies. You just need to write the code, and all dependencies will be managed completely automatically. And as a final stage, we can see the description of the project itself. So this is a description of database object. This is a description of logical units. Yeah, your logical unit name Jaffle Shop as our project. There is a data inside which should be populated into corresponding logical entities with those logical data types. Yeah, and also the same logical models for the data. So you can see the logical entities, you can see the physical implementation of those entities on the database side. You can see the lineage of the processing of your data. In our case, this is just customer table, but certainly you can just click here, not here, sorry. You can just click here and see the whole data lineage for the for your project. I understand that this example is quite synthetic, and it probably even not looks like the real life demo, but in the other hand, we have a limited amount of time, and probably you will have some questions. So from this perspective, let me stop the container, and after that I will be ready to hear your questions and probably your suggestions about this tool.